Okay, this is day 4 and the math section. So we're starting off with a problem based on baseball cards. And it says that a student has a collection of baseball cards. He's collected over several years. B is the number of cards in the collection. And T is the time in years since he started collecting. And we need to basically describe what each of these following equations could mean. So first of all, let's review what a linear equation should look like. We have y equals mx plus b. M is the rate of change or slope, and then b is the initial value. So I'm using these instead of slope and y-intercept because when we have a description, when we have context, these make a little bit more sense. If we have a graph, then slope and y-intercept make more sense. Okay, so it looks like these equations, they're written in a little bit different order. So instead of y equals mx plus b, it's y equals b plus mx. It's fine. It's the same thing. M is still our rate of change. B is still our initial value. And we can rewrite that in a different order because we have commutative property of addition. So this is the way it's written. So let's focus on that. All right, so the first one, 200 is the initial value, and then 100 is what is changing over time. So remember, T is in years, B is the number of baseball cards. So we just have to write a quick sentence that describes what these equations could represent. So for the first one, the initial value is 200. Okay, so let's see, there's no name, so just a student. So let's just say the student started off, and this is not the only way you can write it. You can write it in your own words. The student started off with 200 cards, and so it's adding, so bought, or you don't have to say bought, we don't know that. Maybe collected, saved, traded, we don't know. I'm just going to say bought because he's getting them, and bought 100 cards each year. So let's think about the problems we've done in the previous days and our key words, right? We need each to denote the rate of change. So that goes with the 100. So 100 cards each year per year. And then started off, initial value, 200. Okay, so the next one. Almost the same, except that this time the student started off with 100 cards, and I'm going to say something different this time, and was given 200 cards each year, right? So as birthday gift, Christmas, whatever, was given. So it's still taking it, so adding to the collection. Okay, so the next two equations, we see there's a subtraction. So something's a little bit different here. Can we think of things that would cause a collection to decrease? I could think of something like maybe he sold or gave away cards. Maybe A and B was, as a student, so as a young person, and then he acquired all these cards, especially looking at C, the initial value, that's 2,000. So maybe now he's an adult, doesn't really need the cards anymore. Maybe goes to a collector and sells a few each year. All right, so the student, you don't even have to say started off. The student had 2,000 cards initially, and then I'm going to say sold, and then sold 100 cards each year. Okay, in Y year, why are we saying year instead of like day or month or something like that? Because it tells us. Okay, so we have to use what statement. So years. Okay, and the last one. Start off with 100 and sold 200 each year. So let's just think about that. Is that even possible? So if you have 100 cards and you're selling 200 or giving away or losing 200, can you even lose 200 cards if you only have 100? So, I mean, honestly, as a teacher, I would love to see someone actually say, no, this is not possible because if I only have 100 cards to start with, I cannot give 200 away, right? Now, think about this, 200 per year. So by 6 months, I would have given away 100. So it would have been all of them. So it's the same equation, but the time frame kind of ends at 6 months. So, which is a lot more information than what we're given. So, yeah. But, generally, like the most generic answer would be start off with 100 and gave away 200 every year, right? But in reality, that's not what happened. So I am going to say, actually, the student had 100 cards and gave them all away, so 100, in a half a year, in 6 months. Okay, does that make sense again? So just repeat. So the rate is 200 per year. So you don't have 200 to give, you only have 100. So how much time would that take to give away your starting amount? So just be half of the year, right? This would be an amazing question, and would love it if students could give this answer. All right, moving on. Another rule 4, we have the equation. We're going to identify the slope and the y-intercept. So remember, same as I just wrote on the other page, mx plus b. So that's our slope, that's our y-intercept. So slope is 2, y-intercept is also 2. Okay, create a table. This time it's just x and y. We don't have c and p. So x and y. So again, just choose what you want. It doesn't have to be this. It can be any numbers, 0, 1, 2, 3. So I'm going to substitute 0 in for my x. So 2 times 0 is 0 plus 2 is 2. If I put a 1 there, 2 times 1 is 2 plus 2 is 4. And again, we should see the pattern that we have here, which is adding 2 each time. So this would be 6, this would be 8, right? So let's confirm. 2 times 3 is 6 plus 2 is 8, so that works. The rest I'm going to leave up to you. Since it's just x and y, you can come up with any sort of description you want. Okay. Here we have some more function practice. We have a table, and this equation is just 2x. So 2 times whatever number is here. So that's all we're doing. That's our instruction. So multiply by 2. 3 times 2 is 6. 4 times 2 is 8. Okay, and then what answer is matching that? D. Okay, number 2. The graph shows how much money Mike spent on mangoes. If Mike purchased 35 mangoes, how much money did he spend? So 35. Well, there's a lot of problems with this. First of all, if we have money, what did I say? It's supposed to go on the y-axis, so this is backwards. Also, it looks like it was copied, like the outer parts. You see the x or the y-axis doesn't really line up right here. So that was like pasted on top of the graph, but the problem is, look where the numbers are. They're in between. We don't put numbers in between. We put numbers on the line. So this is all sorts of messed up. And that happens. I mean, humans make this kind of stuff. They make textbooks, so there's mistakes. So I'm going to just kind of mentally scoot this over. So the 10 should be there, the 20 should be there, 30 there. Okay. Anyway, he purchased 35 mangoes. So these numbers match up okay. So here's 35. So there's our line. Okay, so we're going to follow that. And remember, we have to scoot this over in our mind just a tiny bit. So instead of here, it's really here. Then we come down, and then that's going to be 60. And here we go. Okay. I mean, really, just looking at our answer choices, there's only one that would even make sense because we're asking how much money. So 3 comma 4, what is that? That's not money. 2 comma 1, it's not money. The only one that makes sense is C. So even without realizing that there's a problem and figuring it out, we knew which answer it should be. Okay, number 3, complete the table. So this time our instructions are to add 2 to whatever x value we're given. So 1 plus 2 is 3, 2 plus 2 is 4. Okay, 3 comma 4, that's A. And then the last one, we're going to add 3. All right, so we have negative numbers, so let's be careful. So negative 1 plus 3. Okay, it's the same thing if I rewrote it as 3 minus 1, which is 2. Negative 2 plus 3 is the same thing as 3 minus 2, which is 1. Okay, so 2 and 1. All right, so that's B. Okay, and then we have our last part. This time, instead of solving an equation, we have exponents. So this is one of the last things that we did. Remember the rules of exponents. So what does this number tell us? It's repeated multiplication of the number inside the parentheses. So please use parentheses to make sure you have that negative in there as it should be. And then just take it piece by piece. So the first two, negative 5 times negative 5 is positive 25. Okay. Times negative 5 again. So 25 times 5 is 125. But we have a positive times a negative, so that's going to make it negative 125. And you can use a calculator to check this. It's fine. Okay, and then the rest I'm going to, again, leave up to you. And that should be the end of day 4.